So more elimination. We did 2 days of substitution. This is day 2 of elimination. Okay, and they are a little bit trickier than yesterday. I want to go back to the worksheet from yesterday. Oh, which isn't here for some reason. Let's take a look at the worksheet from yesterday. Here it is. And you could go through this worksheet, even if you didn't answer all these questions. You could go through every question and ask yourself, what am I going to eliminate and how? Can somebody explain how you know? Like, how do you look at this question and figure out what's going on? You would have had to do this in the learning goal today. I know somebody needs to do that. Amelia, how do you do it? When I look at question B, like what do you think about? What do you start? What are you looking for? You're going to subtract. Why are you going to subtract? And which one? The x's. The x's have the same number. They're both 2. So if you subtract, you're going to eliminate x. That's the conversation you should be having with yourself in your head. So I'm going to subtract for this one and eliminate x. I'm going to subtract for this one and eliminate x. I'm going to subtract for this one and eliminate x. What about E? Right? I'm going to add and you're going to eliminate. Very good. See, so that's part of the understanding you need for elimination. 6y and 6y. The x's are not going to eliminate because they don't have the same coefficient. The numbers are different. But in this case, and we add because the signs are the same. So when I add, I get 0, right? That's the understanding that you need to have. So then again, eliminate y's, but I'll subtract. Eliminate x's by subtracting and so on and so forth. You can go through all of them, right? What would you do in this question? What would you do in this question? And keep going. That would be worthwhile doing in your MSIP. You don't even have to write anything. You just look at it online and go through and do it. Does that make sense? So when I look at this question, given what we learned yesterday, what do you think? Lexi, do you have any ideas? Not sure? Ryan's got an idea. Anybody else? There's no right or wrong answer here. I'm not expecting you to know what to do, but what do you notice? Something should jump out at you. Corbin? Nice. Well, if you multiply 3 by 2, yes, you get 6. Very good. What else? Ryan, what were you going to say? Okay, good. Okay, good. Yeah. So you guys might have noticed this too, but nothing's the same. Yesterday, all those questions, go back and look at the worksheet again. All those questions, either the x coefficients were the same or the y coefficients were the same, and that's not the case here. You can't just add or subtract. It won't eliminate. So this is where we have this extra step that I told you yesterday we would skip. And so today, what we're going to look at, we don't even have to worry about 1 right now. We're just going to look at 2. So take a look at what it says, and then I'm going to show you what it means. Multiply one or both, just one for now, of the equations by some number so that you make the coefficients the same, so that you can eliminate. So you're going to set it up and design. Now this is a little bit strange. Okay, so let's name these 1 and 2. This is a little bit strange, but if I multiply one of the equations by a number, we've never done that before. We're doing a lot of new things these days. Can you multiply one of them by a number and make it so that it's got the same coefficient as the other one? Ryan, what do you think? So what would I multiply by? And this is a really good example of why a lot of people probably asked over the last few days, why do we put these numbers in circles? I don't understand why you circle them. What a waste of time. I'm not going to do that. But here's why. Because if I didn't have a circle, it would look like 2 times 2, which is 4. And that doesn't make any sense. But now I can communicate, I am multiplying equation 2 times 2. There is a reason why for everything that we do in math class. It's just not always obvious. So 3x times 2 is, thank you, 6x. Negative 2y times 2, negative 4y. And 12 times 2 is 24. And now look what I have. So 2 turned into 3. And so it's like the same equation, it just looks different, right? But 3 and 1 both have a 6x now. So I set it up that way. And as always, whatever you do to one side, you have to do the other. You can't just multiply the x by 2. You got to multiply everything by 2. That's what maintains the relationship. And now it's the same as yesterday. So that's it. There's this one extra step. Now it's the same as yesterday. So what would I do? Kareem, what do you think? We're eliminating. Not sure, that's okay. Yeah, so in other words, add equation 1 and equation 3, right? And that's going to eliminate the x. So negative 6x plus 6x is 0. Negative 5y plus negative 4, get out your calculator, it's negative 9y. I could see a lot of people making that mistake. And 3 and 24 is 27. Divide by negative 9, divide by negative 9. Y equals negative 3. I'm going to be very clear here. When you are doing your homework, you should always find both x and y. I skipped that step yesterday. I went and did it later, so it's online if you want to look at it, but I want to make sure nobody thinks that's how you do elimination. So I would always on a test or in my work, 4 into, I don't know, what do you want to do? Let's go into 2. The numbers are a little bit smaller. So 4 into 2. So 3x minus 2y equals 12. And y is negative 3, right? Goes in there. And that's 3x, negative 2 times negative 3 is positive 6 equals 12. Subtract 6, subtract 6. 3x equals 6. Divide by 3, divide by 3. X equals 2. Always be thinking about what the purpose of this is. We've got 2 lines. We're trying to find where they cross. That involves an x and a y. The point of intersection is 2, negative 3. Right? This is what your answer always has to look like when you're doing linear systems. It's a point. So it's got an x and a y. We skipped that yesterday, and I'm going to skip it in the next 2 examples because I think you don't need to watch me do math. It's better if you're doing it. But that is part of it. Ryan?
Do you have to write the 0 again?
No, definitely not. Questions, questions, questions. Let's try another one. Equation 1, equation 2. So on the test tomorrow, there's 2 questions substitution, 2 elimination. You got to use the right method for the right question. If you solve the elimination questions with substitution, I'm sorry, I can give you very few marks for that, right? Or vice versa. If you use elimination for everything, you're going to lose a lot of marks because we need to see both methods, that you know how to solve both. That's what we're learning. So if this says solve by substitution, I can solve for y and sub it in, right? Like that would be an easy way to do it. Some people might prefer that. But this question says solve using elimination. So I have to go into elimination mode. And what's the first step of elimination? Joe, what do you think? Yeah. Even before that, we're going to examine it to see if it's already done. Is it? No. X's aren't the same. Y's aren't the same. Right? So you're just like, it's almost like you're planning your attack. You're analyzing the defense. Like, what am I going to do here? What's going on in this question?
In this equation, could you do like either one since the variable is...
Absolutely. Yeah.
Absolutely.
Yeah, very good. Could you do substitution or elimination, you mean?
Yeah.
Yeah, this would be nicely set up. a little bit of work, you could do both. But on the test tomorrow, I might tell you you have to do elimination, right? But in the future, we're going to start solving problems eventually someday with this stuff. And then it would be like you use whatever method you like best. Yeah. And for this one, yeah, you can use that for sure. Okay, so what am I going to do? So now the next question becomes, how do I turn one of them into the other? Is like how you could think about that. How am I gonna get the x's the same or the y's the same? Like, what will that do for me? Nice. Anybody have a different plan? That's what you just say that? Yeah. That's okay. Good though. That's good. Came up with it on your own. Vanessa, what do you think? Is there something else we could do? Dividing, somebody asked that this morning, or in the class before this, could you divide? Technically, yes, but I wouldn't recommend it. You're probably going to end up with fractions. So you're looking at the coefficients. How can I turn one into the other? Go ahead, Ryan. I can multiply equation 2 by 3 to get the x's the same, or I can multiply equation 1 by 2 to get the y's the same. Both work. Neither is better than the other. Whatever jumps out at you first. Sometimes there might be one that works better, sometimes there's not. Okay, so let's give it a try. So what did we come up with first? We said we were going to multiply equation 1 times 2 to get the y's together. So that's negative 6x plus 2y equals negative 4. Call this equation 3. And that came from 1. So I'm looking at 2 and 3 now. And they have opposite signs. So 2 plus 3. There's a lot going into this, folks. I said this at the beginning of this week. We're going to learn some big stuff. It's hard stuff. So if you're ever going to kind of like buckle down and really practice, this is the time to be doing it. Okay? Say that again? No. Okay, so x plus negative 6x is negative 5x. Negative 2y plus 2y is 0, so that's gone. And 4 plus negative 4 is 0. Divide by negative 5, divide by negative 5, which doesn't really do anything. X equals 0. I would call that equation 4. And what would I do next? Go find y. Why? I added. Remember this over here on the side tells you what you're doing. So we did equation 2 plus 3. So 1x plus negative 6x. Yeah, that's good. Any questions? Any other questions? Take a look at one more example. It's a little bit different. So again, this one's not finished, right? You would continue. I want you to try to go through the steps just in your head. You don't have to actually solve it right now, but go through the steps of how you would approach a question like this, again, for solving with elimination. How do you start the question, and then how do you proceed? So you write it down, but while you're writing it down, think about, like, what would you... Is this the last example? You pick. Either one's fine. So what do you notice about this question? What's the first thing that we think about, Michael? Good. You're right. What else do you notice, Ryan? Okay, interesting. Sadie, what do you think about it? Like, if there's anything you notice, no right or wrong answers here. Nothing? Hannah, do you have any ideas? What's the first step in solving with elimination? What did we look at with that worksheet from yesterday? Or the examples from yesterday, if we look at them? Same coefficient. Same coefficient. Same coefficient. So what's happening today? You should be able to ask this question of yourself. The first one, analyze it. Are the coefficients the same? The answer is no. So how do I turn one into the other? Ryan already helped us with this. Can you turn a 2 into a 5? Not easily. Can you turn a 3 into a 5? Not easily. So we have to multiply both. So this is going to be the sort of most challenging type of question we're going to see. We'll talk about that after, okay? It is definitely something you need to know how to do, yes. So this is, and it's kind of like common denominators. You have done this sort of thing before at some point in your mathematics career. Okay, you have. But it is tricky. So how do you learn something that's tricky? It's not unreasonable for you to learn this. You just got to practice a little bit. You got to try it a little bit. The first few questions you practice will be easier. And then when you start to get comfortable with that, you try a harder one. Okay, so anybody have an idea? What can I turn both of either the x's into or both of the y's into? To do what? The x's for both have to be the same, or the y's for both have to be the same. You can, yeah, which one? The x's, right? You can turn both of those into 10. So how am I going to do that? I'm going to do equation 1 times 2, and I'm going to do equation 2 times 5. So that's what we call a common multiple. You're looking for a common multiple of the coefficients. What would be common between 3 and 5? 15, right? Good. Okay, so let's try it. 1 times 2, so this is negative 10x. 3y times 2 is 6y. And don't forget to multiply the other side of the equation. A lot of times people forget this. 4. 2x times 5 is 10x, so we line those up. We got those right. That's what we were trying to do. Negative 5 times 5 is negative 25y, and 3 times 5 is equals 15. There's equation 3. There's equation 4. Now this is a question just like yesterday. What do I do? What do I eliminate? How do I do it, right? You start asking those questions again. Now we've got 10 and 10, so it's set up properly. Nice. So I'm going to do equation 3 plus 4. And just very quickly, 10 plus 10 is 0. 6 plus negative 25 is negative 19y. 4 plus 15 is 19. Divide by negative 19, divide by negative 19. Y equals negative 1. I would call that equation 5 and keep going to find, we found y, now we need to find x, right? So you would keep going, but we'll stop there. Any questions?